So next we are going to be calculating the internal forces on the system due to the action of the unit force at point K. So assuming that our unit force at point K is in the horizontal direction towards the right hand side, magnitude F n is equal to 1, then at this hinge here we shall be having an opposite reaction, that is Fp is equal to 1. Then if that is like that, here we shall be having an internal force of -1. Then upwards we shall be having internal force of -1. Likewise here also, then negative, if we have -1 here, this would be a √2 times 1, which is equal to √2. So since we have the same, like -1 and 1 here also, it would become a √2. So having found our internal forces, let's now move on and calculate the displacement. So from the above, we say that our displacement delta, that is delta k, is given by 1 over EA, then into the integral. Since here we are having a continuous structure, it will just be the same as the summation of the forces, Fp times Fn. So this one here would be equal to 1 over EA into, so we have to consider each truss at a time. Now when you look at this one here, the Fp is equal to 0, then even for here the Fn is equal to 1, when you multiply the two you get a 0. Then for the sake of this one here, the Fp is equal to 0, and here the Fp is equal to √2, so they cancel out. Now we are left with how many? We are left with three of them, beginning with like this upper one here. Here we have our Fp as negative Fp, then times our Fn, which is equal to -1, then plus, we move on to the next. Say we take this one here, we have it as -Fp, then times our Fn is equal to -1, then plus this one here, the slanting one, we've got this as negative Fn,